All right, so yeah, about 7 years ago was when I started at Parasoft as a Java developer for our SOA test product. Then after that, I was solution architect and sales engineer. And since it was a small company at the time, I also ended up doing a lot of trainings, both like from design to delivery for our products. And they sent us out to do consulting. So I got to see the software industry from several different angles. And now product manager for 1.5 years of our language tools, which comprise JTest, C++ test, and .test for the respective languages that you can guess. So it's been a fun run, and now what do those products do? Real quick, I know not to be salesy. It's static analysis, unit testing, runtime analysis, and peer review, automated assignment, primarily. So the presentation today, how to use and abuse unit tests. You're going to see a lot more abuse than use, just because it's more fun. Let's get started. We'll do a quick introduction to Parasoft. One slide. Then we'll set some definitions, because when we hear the term unit test, different ideas come to different people's minds, especially if those people happen to be managers. Then, should I unit test? Some people have very strong opinions on this one way or the other. I need a balanced perspective as much as I can offer. State of code testing technology. So what can you realistically expect from a tool in general when it comes to unit testing and auto-generation and stubbing and mocking and so forth? Then we'll close out with the use cases and the abuse cases. By the way, feel free to interrupt me at any point with questions. Just raise your hand. I actually work better when I'm interrupted. I get to play off of people. It's fun that way. All right, so who is Parasoft? We've been around for, it says 26, should say 27 years. Founded by a Caltech PhD in physics, Adam Kalawa. Privately held, so we don't have to deal with any VC funding. We don't have any debt. We choose our own destiny, which is nice. Lots of customers all over the place, primarily enterprise-type customers. And we've been profitable the entire time. Lots of patents and growing. Great place to work. All right, so quick survey. Show of hands, 2 slides on this one. Who here does unit testing? All right, that was about 20 to 30. Nice. Maybe 2/3 of the room. And who actually writes them manually? Same number. All right. Well, that's what we'll find out today. Use any sort of stubbing or mocking frameworks? Fewer people, more like 20 that time around. You want to unit test more? Think you don't do enough? Way fewer hands now. Don't know, about 10. We'll get into the why. Is it because they're a waste of time? 0. Awesome. I like this group. There was 1? Say what? You wish they were easier to maintain. The maintenance is probably the real issue there. Okay. Back up to 15. Clearly very scientific, right? Okay, how about creation of the unit tests? You wish they were easier to write in the first place. Well, I've seen a lot of the same hands. Yeah. Has that happened to you? Yeah. Is it still living there? Is it still like running? Smart move. Okay. Who here heard of Parasoft before now? 5, 6, 7. Okay, need to yell at the marketing team. Now, pretty much expect all the hands to go up on the first one. Who codes in Java? OK, then. Now, in addition to Java, who codes in C and C++? OK. All right. And .NET? See, that's generally what I see is way fewer .NET than either of the others, although .NET seems to be gaining popularity ever since they released the framework 4.5. Objective-C. 3 people. All right. Hardcore on the mobile there. Android? OK, 6. Last one, something else, some other language. Oh, back up to 20. 21. Cool. Thank you for that, for indulging me. Just good to get a feel for who's in the audience, what types of stories I can tell as I go through. All right, so just to make sure we're all on the same page, unit test, regression test, unit and test separately. Not to be pedantic, just to make sure when I say the words, you know what I mean. So unit, I think in physical terms. Like when you have a unit of measurement or a unit of distance, that could be a mile, it could be a kilometer. It's not specified, right? So if you talk about a unit test, what level are you testing at? For my purposes, I generally mean at the level of a function or method. If I deviate from that, I'll try and say so. I'll call it an integration test, or a scenario test, or a functional test. OK, so a test. This one's important. I only consider it a test if it passes or fails, strictly, in exactly one way. It tests one specific thing. If you have a test that tries to do too much, it's one of our abuse cases later, you run into problems. So in general, a test is something that when it passes or fails, you know exactly what that means. So putting the two together, something that strictly passes or fails, and you know exactly what it means at the level of a particular method. Now, regression test, a particular subset of unit testing. The regression test's sole job in life is to tell you something changed. It fails when there was a change. It passes when things were exactly the same as before. And we'll see why this is important in a bit. So why unit test? Speaking of stories, I've actually heard some of these things said by various people in my time as an SA. Well, unit tests aren't actually that useful. Functional tests are way better. We'll just stick with them, thanks. Oh, this one's great. Management won't let us unit test. They say it's too time-consuming. We have to justify the ROI. Why else would you not unit test? Well, unit tests can be very noisy. They're so granular, they're so brittle, we'd rather not deal with the problem. And last, they take too long to create. So yes, going back to the survey questions, just wanted to make sure what I heard was a general sentiment. People feel like, I really wish I could just make this thing happen way, way easier, because it's so much of the same thing, writing the harness and writing all those common pieces to all of them. And then you finally get to that point where it's the interesting piece, and that can be done rather quickly in comparison to the whole harness piece. OK, so when would you decide to unit test, given all of these constraints? Why would you say unit testing is for me? Well, one of the examples is they're complementary to functional tests. It's not an either-or type of game. So if you've got the integration test, you've got the functional test, you can still unit test, and you can gain a lot of value from them independently. Preaching to the choir. OK. So if the management is fighting unit testing, saying we don't need to test. Well, these are the same people that when the product fails in the field, they ask you why you didn't test for that, right? So apparently it matters at some point, just not when they want the product now. So generally when you find management saying, no, we can go do away with testing, it's because they don't have that visibility. They don't understand these tests map to these requirements. This is what we're losing by not running these tests. They can be managed. Maintenance does not have to be a huge pain. There are ways around it. There are ways to make management of unit tests easier. And lastly, they can be auto-generated. If you're spending a lot of time creating them, it's possible to get a whole bunch right out of the box, get a jump start on it, and not worry about the minutia. And of course, we'll cover that. What's the current state of auto-generation? Well, one is scope selection. Some people think that they're going to take their entire application and generate tests for the whole thing, and then run through the results one by one and see if they're right. Well, really recommend against that. There's better ways to scope it, better ways to say, well, here's what I'm working on right now. Here's the code that I'm about to touch. Let me freeze frame that stuff, and then only make the changes I need to make and see if anything breaks along the way. There's lots of different ways you can choose that scope. Then there's the boundary condition testing. Given a particular function, you can test certain things that you know you'll always need to check for. And when you're thinking in terms of, I've got to build this feature, I've got to make it do this thing and that thing, you might not be thinking of the error scenarios. Really easy for both the boundaries and the heuristics to knock those out for you. The nulls, the empty strings, the really long strings, so forth. Next, these tests can be used to drive coverage carefully. We'll get into the details there once we get into the more technical aspects of the presentation. We're just setting the stage now. But yes, auto-generation technology can drive coverage for you. It can get most of the coverage out of the box, and then you get to concern yourself with the remaining 20 to 30%. And by the way, that coverage includes things like MCDC coverage or loop coverage or any of the more advanced types you can imagine. Good question. MCDC stands for Modified Condition and Decision Coverage. It's a hybrid of your simple condition coverage, which looks at each individual. Let's say you have an if statement with several variables, and ors and ands, grouping them together in some way. Each individual term is a condition, a simple condition. And then they build up into decisions. So now you group them after the operations, the logical operations are run. And those are your decisions. And then the modified condition decision is a hybrid that says, well, OK, I don't want to do every simple condition everywhere possible because I will spend my entire time testing and I don't happen to have a Cray supercomputer on hand. So how do I choose a basis set of variables that lets me still get really good coverage, make sure that I've tested the important pieces by some definition of important, and have a nice small set that's actually manageable? So that's the goal of MCDC. OK, stubs. We can auto-generate stubs. And when we say stubs, they could be one of several types. In the Java world, it's more at the test case level. You'll define a stub for various functions that might get called so you can isolate a component. In the C, C++ world, you also have stubs that live independently, and you can modify their behavior based on which test is running. So different paradigms out there. The most popular one that I'm seeing, though, is the really granular test case level type of stub. That's across language. And lastly, what about user intent? And I got a question mark there, and we can talk about it in a little more detail once we get through all the others. I'll let that just sit with you for a little bit. Can we take into account user intent? All right, so the boundaries. I mentioned a few of these, like the empty string, the very long string, the null. Got to make sure you test for 0 and 1 when they're integers. Maximum and minimum integer as well. OK, well, what about something more complex, right? What about classes? What about connections to databases, right? How do we manage those? Well, you guys know this. They all break down into primitives eventually. And we can interpolate those based on an understanding of the code. So fundamentally, we can construct these objects. Are they always meaningful? Depends on your definition of meaningful. Can they get the code coverage? Absolutely. Can they follow paths you might not have considered because that could never happen in the real world? Yes, they could. By the way, where do you think most of the bugs live? In the code that could happen and you accounted for, or the code that will never happen ever in a million years? OK. Heuristics. So this goes one step beyond. Now we're looking actually inside the code, and we're finding strings that were defined in the class. We're finding the cases in a switch statement. We're looking at the logical conditions and seeing, can I make that thing be true or false by setting certain variables? Oh, and another one that people tend to overlook is forcing exceptions to be thrown. People think, I don't need to worry so much about the exceptions. Again, that's not really going to happen. I'll get a file handle. File names are never empty. Okay, when I say about driving coverage, what can an automated test generation system do? Yeah, it starts off with the heuristics and boundaries, and it can trace these paths through your function. It can figure out how many paths there are and whether it can traverse them. And that's also going to leverage another technology called static flow analysis. Who here has heard of static analysis, by the way? Ooh, fewer than I would expect. OK, so static analysis is a technology that looks at the actual text of the code, or in some cases, it looks at the bytecode. And it can find various types of errors without having to execute anything, just by inspection alone. So people who adopt static analysis, I know this is a bit of an aside, people who adopt static analysis find that they have much more interesting peer reviews because they're not worried about those minor errors any longer. They can focus more on architectural type things. And in fact, in one of our abuse cases, we're going to go into a bit more detail on this. Yes? Excellent question. So this might be a Parasoftism, to be fair, but we divide static analysis into 3 categories. One is pattern-based static analysis. Strictly looking at the text, you can match it kind of like a regex, not really. It has a little more knowledge than that. Flow analysis understands the values that variables will take on. We actually create an execution graph of the code, and then we can traverse that tree. OK, we turn it into a tree. It's not a tree in real life. Then we can traverse that and say, OK, so you set this to null over here, and then you never changed it, and then you dereference it. That's the flow. And then the metrics is what you would typically think of code metrics, right? Your complexity. McCabe's very famous, and everyone asks for it, but then nobody uses it. So what turns code metrics into static analysis? It's that you set a threshold. So if you're serious about code metrics, more than just measuring it and creating pretty graphs and saying, look what we did, if you want to actually do something about those metrics, get them within certain thresholds, we can help with that. You set the threshold, and that becomes a static analysis violation when it gets outside of that range. Yes? I'm aware of find bugs for Java that does the basic pattern analysis, but I haven't seen the metrics or the flow analysis from that. Oh, there is. Thank you. So does DTP. Parasoft DTP. You name my competitors, I get to pitch. Okay, what about stubs? So they can be auto-generated, or they can be manually configured. Naturally, you're going to use a hybrid of both. What are they primarily for? Yes? Great question. So some people use stub and mock interchangeably. So yeah, just having been at Parasoft 7 years, I think stub before I think mock. Yeah, the other thing is it's very easy to incorporate any number of mocking frameworks into an automated unit test system because they're generally just represented as libraries. They're included as part of the class path. So you can use a mocking framework and then drive that with auto-generation or supplement your auto-generated tests with the mocking framework. It's just whether you want to use what we have out of the box or you want to use something else. Thought I saw another hand. Okay. So yeah, the best use of these I've seen is in 3 primary cases. One is to mock out a data source connection. Another is to mock out a web service call of some sort, because why actually call a web service and get an XML payload or a JSON payload when you can just create it yourself to the exact conditions that you wanted? And then lastly, to really isolate a class or a particular module, like a package level. So this is where we're starting to differentiate between a unit test and a unit module integration test. It's all where the stubs and mocks go. Yeah, we can't figure out user intent. Not yet. I've had this question more than once. Look, the function has this name, and it was supposed to do this thing. Why can't you just figure out that I did my algorithm wrong? Well, because we're not in the business of replacing developers quite yet. But maybe one day. 20, 30 years. All right, into the use cases. Hope I'm good on time. So use case number 1 is legacy code. And at dinner, where are you, Chris? You were asking about legacy code. So when you're dealing with a legacy code base, different companies have different restrictions, what you can and cannot do. But the common theme here is there's this huge chunk of code, and nobody really knows what it does or how it works, and it's got this great amount of business logic to it. We really don't want to touch it, but we also kind of have to. We're going to make changes. We're going to migrate to a new platform. We're going to do something that means we can't ignore this spaghettification anymore. So how do we do that safely? What are the different ways that we can address this fear? And here is where regression tests are really beautiful. Stupid regression tests. Those low-level, brittle regression tests that people normally hate are perfect in this situation. You target this legacy code with your scoping mechanism. You auto-generate your tests. Then you run them. If anything fails, just remove it. This isn't normal functional testing. You're not trying to prove you've developed something. You're trying to get a baseline that always passes at a very granular level that tells you whether or not this thing changed its behavior. So now you've got your large set of regression tests, auto-generated, and you can go about your day. Start changing the code with impunity. Okay, sure, there was some dynamic behavior there. If it's really important, go ahead and target those pieces that were the dynamic behavior and create your functional tests. At least we took a huge chunk out of the manual labor for you. we're into the demo period. XKCD is an awesome comic. I recommend it to anyone with an engineering or mathematics background. Okay, so how does this legacy code example work in practice? On the other screen, that's how. There we go. All right, so simple example project. Doesn't actually compile into an executable. It's just a whole bunch of jar files, but it gets the job done. So let's say this package represents my legacy code that I have to go in and change. What I want to do is I've got no unit tests yet, nothing up my sleeve. Just plain old Java classes trying to do their thing. Some kind of bank ATM thing going on. So what I tell the tool to do is generate and run the unit tests. So it goes through, and exactly like I described, it's going to try and find the paths, find the heuristics, find the patterns, and start pumping data into the public methods of all these classes. Cool, database null. So at the end of this, what did we get? 66 test cases generated and 9 unit test classes. 9 out of 10 files were checked. Let's see, which one was not? I'm betting the abstract transaction. And that all took us 12 seconds. So anyone here could do that. Not impressive. So what are these? We executed these tests. What kind of results did we get? All right, so we got a null pointer when we tried to do an assert equals. That's interesting. Well, what did I say we were going to do here? We're just going to blindly assert, right? At the very least, I can say it's supposed to be a null pointer every time. It is, yes. So I could skip, I can delete. Yeah, let's delete. There's our assertion failed. Expected 0 was -1. Let's change the expected value. Oh, don't be silly. Expected. I haven't looked at this in a while. Gotta correct somebody's English. All right. In any case, there must be an easier way, right? Well, luckily, there is. Let's get rid of those. They're auto-generated, so they don't. Doesn't hurt to kill them. Can always bring them back. Let's see what other options we had here, because just some crazy built-in configuration. Who knows what it was doing? There must be a better way. All right, that's more like it. So maybe I do a thorough symbolic analysis. It'll take longer, but it'll get more of those cases out. What else? Throw in report exceptions? Absolutely not. I want to catch and assert all of them. External resource? Yeah, that sounds good to me. I'd like the package to be what I'm testing rather than the individual classes, because that's just me. I can run a second run if I want to also isolate the classes. Really your call if you want to go after private methods directly or try and enforce that those private methods are called by the public ones. Obviously, this is context sensitive based on what you do know, what you don't know, what scares you, what doesn't. Yeah, the one thing you don't want to do, this is that scoping part, with up-to-date test classes, that will overwrite whatever you had. Unless you absolutely intend to do that, don't do that. We have a hash for the test file. And the other thing that we do is we know the authorship. There's an @author tag. And by default, we say it's JTest version number. So if we see that JTest wrote it, then JTest can overwrite it. If that's changed to anything else, then we won't touch it. All right, so I'm pretty happy with that. This time, I'll run my user-defined test using. Has it now? See what we get out this time. So remember, I turned on thorough symbolic analysis. I'm expecting more test cases than before, unless it was already as complex as it was going to get. 65, not bad. This time, no tasks reported. I already asserted everything. So what happens when I run? And notice, I can select the original code. I don't have to keep track of which tests test which code. The tool tracks that for me. So I just say, well, this is the code I'm modifying. That's the code I want to test. So let's go ahead and run those. Oh, fine. That was quick. Got 2 reported tasks. Dynamic test. And test that was probably already a unit test. So not too bad. Was that total time with explanation, a few minutes to get 65 tests. This is going to hurt my neck. Okay, back to the presentation. All right, well, what about brand new development? Starting from fresh code. Now, a lot of people who hear is agile. Oh yeah, good chunk. That half of the room more than this one. How'd you guys do that? Coordinate? No? Okay. Yeah. So generally, if you're agile, you're probably doing test-driven development type practices. Now, if you're a purist, you have to write the test. Absolutely must write the test first. You can't write any of the other code first. But if you want to benefit from tools, maybe you'll make a slight tweak to that. Maybe you'll say, all right, I can write the skeletons of the function. I can at least provide the types of variables it takes and the return type it gets. Fill them in with nulls if I have to. That gives the test tool enough information to generate data for you. Then the other cool part we're going to see is extending that using data sources. So rather than have to write one test and another test and another test and another test, parameterized from a CSV or an Excel spreadsheet, another thing you can let the tool help you with. JUnit 4 helps us there too. Because good code really is what we're trying to go for here. Of course, this comic thinks that good code comes out of nowhere, and it all ends up being thrown out and started over anyway. Okay, so what does this look like in the brand new development world? Now let's get rid of our old stuff. There's my brand new project that was created before that held the unit tests. Let's go ahead and nuke those. And close the test classes so there's nothing left over. Okay, so now I want to add a new class. And let's call our class Atlanta or Altanta. That works too. There we go. Just something minimal, something that tells it what I'm looking for, inputs and return value. Now this part should look familiar. We're just looking for the Parasoft piece. Oh yeah, test history. That'll be easier. And, well, do I really want the hardcore regression test where everything's asserted this time? Not really, no. Now I'm looking for more of a test-driven development feel. So let's just use the built-in generate and run, little lighter weight there. Two tests. One of them is for awesome, the other is for the constructor. And if we want to take a look at those tests, you can check them out in the auto-generated project. There's Atlanta test. Constructor for the test, the tested constructor, and the test for our function, our method. Pretty straightforward. Now, normal test-driven development methodology. Modify the test, run it, it fails, modify the code, run it, it passes, repeat. Yeah, good question. Well, now that we have a test, we should really parameterize it from a data source. And for that, I'm going to use the test case explorer. And I'll just add parameterized test case. And I can actually choose one of the existing test cases to parameterize here. So we'll select awesome-o. We'll tell it to go after the heuristics and corner case values. Generate a maximum number of 1,000 rows in the worksheet. And personally, I like CSV better than Excel. Yeah, so only primitives and strings works for this case, or we could extract particular class types if those belong to the project as well. It finds them. So we get 8 data rows out of that. And it refactored our code. So what does the refactored code look like? Get your standard setup teardown. We had that before. But now, we've isolated the unparameterized tests so that we could also list our parameterized tests. You're saying we use the JUnit runner run with. That was done for us. Defines the input and the return value. All the parameters that we need to drive our single unit test from the data source. And looking down further, There's our test, referring to the data source. So what's this data source look like? Well, it's right here with the test. It's a CSV file, as promised. It even opened up on the correct screen this time. All right, so it drove it. Ooh, I forgot to list those in the PowerPoint. Really large and really small numbers, floats. See what happens when that gets in there. Well, that's no fun. Let's go ahead and enter those values. Something else that'll fail. Yes, Microsoft, but I just did that. Okay. It didn't. Okay. So now that we've done that, let's check our quality tasks. So no tasks right now. And if everything goes as planned, we had 8 rows. One of those rows was asserted to be the 100 return value that we knew we wanted. The rest should all fail with the correct error messages. We should see 7 tasks after I run this thing. And unless Murphy's Law foils me again, that's exactly what we're going to see. You're all secretly hoping that didn't happen. Okay, but there we go, the 7 tasks reported. And you see it's actually referencing the data source rows for us and telling us the expected value and the actual value. All the information you could ever want. It is. Yeah. Yeah, that's not that I know of. It does. Yeah. Yeah. In fact, let me show you that again. That's now you can control this, but by default, it just takes your project name and appends a .jtest to it. Then it mirrors the package structure and class name. It just appends a test to it. And then right alongside where that parameterization occurs is this CSV file. So you can commit that to your source control system, manage it just like the rest of your code. Okay, back to PowerPoint. All right, now this one's interesting. Test organization. The way that you organize your tests can be a use case and abuse case or one of those on the fence dealies, depending on your organization. Now, tagging and filtering is actually a great way to manage test cases. If you've got the type of system that can do that, that type of integration with various unit test frameworks, you can say these test cases are part of module X. Well, maybe not. Maybe you've already tied it to the code, so you don't really need that information. So then what would we be tagging it with? What type of information is interesting that you'll need to go back to and reference later? Things like requirements that it was associated to, defects that it was written for, whether it's a poor man's regression test or a user-defined test. Things that later you can go back and you can say, man, I really wish I could find that test that did this thing for that aspect of my system. Then later on, in your development testing platform, you can search for that information in various filters, and managers get all the beautiful reports that they could ever want, and you get your actual functional, capable way of cutting down the time, finding the tests that you need, and doing what you need to do with them, including debugging. When they fail, you got to know why they failed, how to fix them, or the code. Okay, the abuse case here is the directory structure. Now, I've seen this played out multiple times in multiple locations. Everyone thinks, no, we just need a single standard for how we organize things. And as long as everyone follows that standard, we'll be fine. We'll be golden. Let me name another system that tried to do this, the Dewey Decimal System. Problem there is you can't get common agreement because no common agreement exists because it's not natural that one hierarchy is more appropriate than another. So whatever directory system you choose that seems reasonable to you or even reasonable to a committee, I guarantee you'll get somebody, even if you put them through all the training in the world, who's going to mess it up every now and then. And once it's messed up, there's no going back. It becomes ingrained, embedded. You just don't have the time to go back to it. This is why tagging and filtering is far superior to managing directly through how they're organized in a file system or in a source control system. Then you've got the test hierarchy. Now, the example I have in mind here is Cisco. Giant organization, tens of thousands of developers, tens of millions to hundreds of millions of tests for all of their systems. What they do is, first of all, not have enough space and processing time to run all of their tests at that granular level. But they still want to test. It's still very important to them to test. So the way that they do this is they set up a hierarchy. So you have these high-level tests. When this test fails, you don't know exactly why it fails, but you know it's one of very many things. So when it fails, its job is to kick off the next round of lower-level tests that figures out that next level, and so forth, until you get to that lowest granular level that tells you exactly what went wrong. Now, if you are a giant organization like that and you have the manpower to do it, more power to you. Most of us don't have those resources. So that's why I'm on the fence about it. Works for some, doesn't work for everybody. It's up to you whether you want to implement it, whether it works for your organization. But it can be quite powerful in the right circumstances. All right, so an abuse case. This one's great. I want to unit test so that I can find the bugs in my application. Okay, sure. Things that unit tests do very well are verify functionality that you built in. They also find changes that were unintended or intended. They don't do so well at finding bugs. They're an inefficient method of finding particular types of bugs. And these are two cases where static analysis would have been a better choice. So let's see why. Just start over again. So we'll get back to the unit test cases that we saw a million times before. Okay, three times before. And we're going to look at two particular issues. That's interesting. Right, it's supposed to be in coverage. Okay, so looking at this coverage, we're play acting now, or role playing, one of those. You just created your tests. You want to drive some coverage for whatever reason. You're trying to target, well, okay, this one looks like some low-hanging fruit. I just have to get one more line to execute in that particular file. So let's go in there and check out the line that we need to get execute. All right, well, it's color red here. It's this throw clause. So all I need is an amount that is less than 0 and greater than 1,000. Okay, what number is that?
Yes, it doesn't exist. Possibly do some funny things with the types to get the type conversion to actually trigger a rollover if amount is a... I'm pretty sure you could do it. You're just beating the hell out of the JVM.
Yeah, that's really clever. I have not heard that one before. Most people, I think, would look at the logic here and recognize that they meant or, not and. So yes, with a unit test, after looking through who knows how many results, after checking out this code, and I'm sure we've all seen more complex code than this and probably couldn't have arrived at this solution as easily as we did in this room. So if you're lucky enough to spot all of that, then yes, your unit test found a bug. How about self-assignment? There's this customer.java. It's hiding a pretty nasty bug.
Actually, if you had tested for exceptions there, you would have found it justifiably with the unit test, no?
Tested with exceptions. Help me understand that.
Well, you said you also need to test for exceptions. You need to produce all exceptions that are thrown in your code. Try and produce this one.
How do you find the exception in the first place?
That's what TDT is all about.
What?
Okay.
Why'd you have to code if you didn't have a test?
Very cool. Yeah, so I can tell you're all very mature organizations. Not a spot of legacy code in there. Okay. So this one is a self-assignment that hides a pretty nasty bug. Didn't actually set the private SSN value. I just reassigned the value back to the variable that was passed in, and that could wreak all kinds of havoc. But as far as my unit test is concerned, yep, covered. Assertion passes. Good to go. Didn't find the bug. So what's the alternative? What's better? It doesn't have to be our static analysis tool. It can be a static analysis tool. Yeah. So we'll run some recommended rules on this code. Took a second. And let's go find our two culprits. One was customer. There it is. Avoid self-assignment that has no effect. Okay. What was the other one? That was within withdrawal transaction. We have a conditional expression that always evaluates to false. Straight to the point. So could you find these with unit testing? Absolutely. Is there a better way? Yes. And if there's any doubt at all, there's always the documentation. And yeah, any tool out there is going to have built-in documentation. Yes, you can. Yeah. Everyone hear that question? Can you configure it to run in the background so you don't have to do it manually? The answer is yes. Oh, minor. You wouldn't even notice most of the time unless you're doing really performance-heavy activities yourself. And most people just put it into their automated build system. All right, next abuse case. The next abuse case is being overly focused on coverage. This is where you get the Harvard MBAs saying, well, we've got a metric, we have to drive towards it. You're not writing enough lines of code, you're not getting enough coverage for your code. Problem with this is, first of all, yeah, okay, maybe the line was executed. It doesn't mean it was tested. I can guarantee you if it wasn't executed, then it wasn't tested. But if it was executed, I can't guarantee you had a test. Number two is, we already covered this, and it's kind of the reason if you're going to use auto-generation, you use it sparingly, you use it knowledgeably. Auto-generation can get lots of code covered. Doesn't necessarily mean anything, right? Auto-generation is best for regression testing or test-driven development. And lastly, there's that pesky 100%. Get those people who are like, we got to drive, we got to hit this number, it's going to be great, we're going to be so high quality. The problem here is you get developers overly focused on this number and less focused on the purpose behind the pursuit. The reason you're trying to get coverage is to get intelligent eyes on the code, understanding what it does, why those variables are traversing that path, or what variables are required to traverse that path, and making sure it does exactly what you expected it to do. If you're just trying to get these numbers and you're in a huge crunch, you're going to do exactly that. Get your number and move on and miss the potential bugs that you were trying to find with this methodology. So be very careful with coverage. Don't just push for it. Do it for a reason. Have a purpose.
So in your opinion, what is that sweet spot when that manager comes and says, I need the coverage? Is it 80%? Is it 70%? In your opinion?
I don't believe in it.
You don't believe in it at all?
No.
Some?
If it's 0, then I know you're definitely not testing. Yeah. But it should be up to the engineer. The engineer knows the code. If you want, you can have a second engineer write the tests rather than the engineer that created the code, so you get that feeling of the unknown, right? Other people are going to think of things, think of the problem in a different way, and come to conclusions that you hadn't considered. But as long as you have tests, and as long as you and your peer reviewer are content with what you have, that's good enough for me.
Is there any, the main thing that I think we found is that 60%, somewhere around that number, you actually have to design differently and more modularly to get above. And it encourages a better design paradigm in order to get coverage above that.
That's really cool. What size team is this?
3,000 developers.
Okay. Nice. All right. Good to know. So about 60%?
I think that's about the level where you might, so we don't hit that, but I'm saying that what we found is that in order to get above that, you have to have a different design methodology, and that tends to drive better quality code more than the fact that you're getting a better code.
Okay. I've actually seen that to hit 100%, you actually got to make your code not good.
Yeah.
Because I've seen, like, I don't know if your tool filters out private constructors or something like that, code that can't even execute at all. But I've seen people, oh, I can't execute it, well, I'll make that public. Well, no, the whole design is make that private, and it's not supposed to be executed at all. So.
We get around that by using Java reflection. Yeah. Gonna make it public behind the scenes, but not really. Yeah. But that's really interesting. Now I have ideas for my next survey. Okay, trying to do too much with a single test. The easiest way you can tell is someone is gloating. Look at this test, it's so cool, look at all the stuff it does. Oh God. What have you done? Yeah, especially if we're talking about something like JUnit, CBP unit, NUnit. They do make such a thing as HTTP unit, which is based on the lower level unit type tests, and it can accomplish some jobs, but there are even better tools out there. And okay, small plug, SOATest does this for web services. And there are competitors, and feel free to name them. No? Okay. So yeah, you can do too much with a test or a framework that's designed to operate at the low layer. If you're creating integration tests with JUnits, there might be a good reason for it. I'm not going to flatly say never do it, but there's probably a better way. Okay, performance testing. I've had this come up so many times. Again, there's a right way and a wrong way. The wrong way is I get people telling me, well, I just want to know how long it took to execute this one test, and I'm just going to run it once or once a night with this one set of data, and I'm just interested kind of sort of how it performs. It's a bad approach. Performance testing is a fundamentally statistical process and a statistical methodology. You need to use lots and lots of different data. You need to really drive this thing with thousands of rows simultaneously so that you can find your standard deviation and your mean and plot what it looks like in a histogram and determine that it meets your SLAs if that's in fact what you're trying to do. Otherwise, you run into the very real statistical problem that you've chosen a magic number that gives you a way outlying answer. And you've kidded yourself for way too long until you get to the release date and your performance testing team or your QA group finds the problem. I thought you tested that. I've seen this one too. Make the tests pass. Just whatever it takes. Turn it green. Yeah, and people get forced into this. It's a bad management practice more than a development practice. Every engineer knows that you don't want to do this, that it doesn't mean anything to just change the color on the report. The test is still failing. But we get forced into it for some reason. And it has ancillary difficulties associated with it. If you're not publishing, if you release and you're not publishing, at least internal to your own company, that these defects exist, that they're known issues, that development's going to get to them, then your support team doesn't know that they're known issues, so that when they pop up in the field, you get a new defect created, and somebody has to go through the whole process of saying, is this the one that we're going to assign to this sprint? And like versus, oh wait, no, we have that, and we already knew about it, and the support guy, because it's published and he can just look it up, can say, oh yes, Mr. Customer, Mrs. Customer, perfectly fine. Thank you for reporting it. Thank you for finding this. Happy to tell you, we already know, and we're working on it. Way faster, way easier, as long as you go back and fix it. Write it up as a feature, yes. Undocumented features. Oh, fair. It's documented in that case. Okay, another abuse case is looking at the percentage of passing tests, because any test is the same as any other test, right? It's not like certain pieces of your code have a higher risk factor than other pieces, except it does. So if you're looking strictly at the percentage of tests that are passing, there are really fun ways to abuse this. I can write a whole bunch of tests that do absolutely nothing but pass, drive that number up. I can stop testing because, you know what? The last test run had the right number, and if I add more tests to it, it could only get worse. Right, so fundamentally, you have to know what's the value of these different tests, right? All tests are not created equal. So when you've got that nice percentage telling you it looks safe to release, at least review what you've got and make sure nothing critical is failing. Yes?
Does that lead you to the hierarchy conversation you're talking about?
It can, yeah.
You get
Yeah, that one, you could approach that with the hierarchy methodology, or you could approach it with tagging and filtering. Yeah, generally, in most of the systems that I've seen, the tagging and filtering would work really well there because you would tag by annotating the code, and then your reporting mechanism into whatever system it is you use will include that tag. You can search on that tag, and you'll immediately know, oh, that's one of the critical tests. In fact, you can create a separate report just for critical tests. Maybe you make sure those are 100%. Yeah. Oh, yeah, last one. You can get the everything's okay alarm type of test. That's the deal where you get that test. Sometimes it passes, sometimes it fails. It's not really predictable. Let's just let it run again. Maybe it'll pass this time. You know what I'm talking about. Yeah. Everything's okay alarm. Just, there are different approaches to that one, actually. It's interesting. I used to say just delete them. Very interesting approach I heard about that one is regarding when you look at them. Most of the time, you ignore them. But when you've got one of those pesky bugs you just can't track down, and you're aware of it because it's in your bug tracking system and you're trying to reproduce it and you're not able to, that's when you start looking at these unstable tests. You might turn up that weird behavior. This I know from our own product in Sure++. I really respect the team lead there, Rich Newman. He knows things about the way the function names are mangled according to which compiler and version compiled it. Like, brilliant man. And this is his advice. And that's the end. Questions?
Are there Maven tools to generate all the tests, are there Maven tools from Parasoft to do all the test generation and stuff?
Yeah, we provide a Maven tool so that we can understand the build, but then our tool still does the generation from the command line. So we integrate through Maven, then you execute from the command line, and we'll, right. Yeah. Somebody, yeah?
Yeah, so how does any test tool or your test tool generate expected results for a test? Does it use like the static way of doing things, or?
Yeah, great question. So what it does is, by default, it takes what it saw. So when it generates the tests, it's actually running them in the background already. And partially, it's doing that to figure out, OK, what's my current coverage so I can generate the next batch and determine if it's improving. The other thing it's doing is saying, OK, I generated the test, I executed the code. Here's what I saw last time. So by default, I'm going to say that's what I should see. It assumes that the code is stable.
The CSV file that you're showing, was that being used as a data source for the test?
Yes.
Can you use like data sources like databases?
Sure.
Okay. I didn't see all the choices in the import screen, so I'm not sure.
Yeah, it's a good question. You can absolutely use data sources or databases.
So if we modify the Excel, then we don't have to recompile. We just run with the new Excel test coverage, and it's going to run all of it. Right?
That's right. Yes. So if you want to go back to that test case and add more data source rows just to the Excel file, you get the benefit of more and more tests without writing any additional code. You can even hand that off to QA.
Does the automated test thing only work for Java, or does it work for other languages?
Works for Java, C, C++, and .NET.
They didn't like that.
They're challenging you. So do you support other JVM languages than Java?
Yes. Not to my knowledge. What did you have in mind?
Groovy, Scala.
We've got some Groovy support in our SOA test tool. I don't think it extends to static analysis. I know we use it for scripting purposes to extend that tool, but I don't think we test Groovy directly. I'd have to get back to you.
What kind of discount code are you giving to AJUG members?
Hey, Charlotte, I think that one's for you.
I'm an idiot. But it must be purchased by the end of the month.
So there was a hand back here. Yeah.
I was going to ask about multi-threading or concurrent test cases.
Yeah.
Does your product provide any additional support for creating or working with those test cases?
I don't know of any issues running tests in a multi-threaded environment. Yeah, this sounds like a great conversation we could take offline. If you have a specific example in mind.
Does this work with targeting code for Android?
Great question. Yeah. So Android is, you probably know this already, but strictly speaking, not Java.
Yeah.
It looks like Java, it talks like Java, but it gets compiled into a completely different binary and doesn't even run in the JVM. It's Dalvik. Yeah. So yes, we have pattern-based static analysis because that doesn't depend on any lower-level binary type stuff.
Mm-hmm.
The flow analysis works sometimes. There's a higher false positive rate just because of the way things get linked together. The unit testing, not at all. It's something that we want to do. The trick is figuring out who will pay us to do it.
Was that like a fork of Eclipse or something of that nature that you put your program into?
That was Eclipse, yeah.
That was Eclipse. Oh, okay.
Yeah, we're a plugin.
Oh, the plugin. Oh, okay. Gotcha.
So for the other tools, for the .NET and the C, C++, we plug into Visual Studio as well.
Is there a plugin for IntelliJ?
Yes.
CodeWatch?
So I don't know that one.
So,
What kind of reporting does it have, other than the views there?
So we can generate HTML reports and XML reports from the tool. And then we also have our development testing platform, which is that dashboarding web-based interface. So we can publish results into that, and that's where all that cool stuff I was talking about with the filtering and tagging and the charts and graphs takes place.
So I noticed that when you generate the tests, it creates a separate project. So presumably the Maven tools will actually create the POM for that project as well?
Good question. Well, you can generate the project wherever you like. So
you can actually generate within that same, as part of your code under test project?
Yeah.
Okay.
Yeah, you could make the code target the same package that the tested class lives in, for example.
I mean, can you run it like source main Java and source main test, and then put the packages up underneath?
Probably can.
I don't think
That's
so.
the typical Maven.
Yeah, you'd still need to call our tool from Maven. Because we wrap it. We're an extension of JUnit rather than JUnit itself. Yes?
Is the intent to use this tool over and over again from scratch, or would the intent to keep it, to check the generated tests in and have them run as part of the CI system?
The answer is yes. The intent is to use the tool to do most of the generation and modification. And then as part of the CI system, you would invoke this same tool from the command line to do the execution.
So it could run from Jarvis and things like that.
It's a full command line interface. So as long as you can call a command line, it can run.
So you've got to put it both on the desktop and on the build servers.
Yes.
So are you saying that the unit tests that come out of it, they're not normal unit tests that I can just run?
Some of them, yes. If you're using the more advanced capabilities that we provide, then we have to add our own hooks on top of it. So some things will work, some things won't if you try and move away.
So what do you instrument for code coverage with? Are you using
We instrument the binary with them.
So it's like so you're actually instrumenting the code as opposed to looking at the JCode code, it's implementing the JVM.
Yeah, well, we're instrumenting the compiled code. The bytecode. That answer your question? Am I missing something?
So
You might be in a
more
corner.
like a covertura, more like a covertura than a JCode code instrumentation. Okay, better enough.
In the case where there's a spurious unit test or a set of tests that get generated that you look at over and over again and always is popping up warnings about it, is there a way to turn that warning off for that particular block of code?
Yeah, there's a right-click ignore.
Will that metadata about what you've ignored be attached to the project in Eclipse, or would it be in a format that can be persisted and be taken into account by your CI system?
Yeah, the format is generally in the form of a code comment. So it would get stored in the source control system. It would get branched with the code and managed with the code.
So if we're using something like SonarQube that's designed to work with the test results from JUnit, are you generating the same kind of results so that we can pull in the information for analytics, or
should be possible?
Is it different?
It's XML format at the end of the day, so we can always transform it into what you need.
Okay.
Strictly speaking, SonarQube's a competitor. So.
I did see the JUnit 4 annotations in the second two I think you generated, but the first one I didn't think I saw it. Was it JUnit 3 or was it something else? Was it not JUnit at all?
It was all JUnit 4.
I just saw like test methods that didn't have any annotations on it.
It was supposed to be generating in JUnit 4 format. Then set it to 3.
One of the pieces you mentioned briefly was, I think it was part of the analytics. If we change the source code, it'll rerun the tests. Something like Infinitest will do. Is that?
It can. Yeah.
Okay.
Yeah. You can rerun it manually. You can put it into your CI system to execute when you commit. The static analysis can run continuously in the background whenever you make a save.
Okay. So, okay, just static analysis, sorry.
I like the CSV feature, but I'm wondering, can you just make it hard code the values in the test and not have a separate file?
Sure.
Or just an array of them?
Absolutely.
Thank you.
I think we're done. All right.